Hey there. So I'm Levi Turner. I'm a senior technical support engineer here in the Raleigh office. My main focus has been on Qlik, and I've been in the company for almost 2 years. So what we're going to do here is go over what is shared persistence and what does it mean for you. We're going to go over a high level what is synchronized persistence, so how have things worked in the past, what is shared persistence, how are things going to go in the future, the limitations of shared persistence, and make notes of those because there are some impacts for some deployments. Sort of highlight the positives of both modes of persistence, which I'll cover later, and then some recommended configurations, some requirements for shared persistence because there are some additional requirements in addition to the sort of general system requirements, a roadmap of where things are going in the future, and finally a sort of brief interlude about upgrading. How do you guys get to there? So, synchronized persistence. This is sort of an architectural diagram of what synchronized persistence means. You can see we have copies of the Postgres database on both nodes, on all nodes. We have copies of apps on all nodes. I will go ahead and go over sort of high level what's happening here. When a node comes online, the repositories talk, they sort of sync the metadata in the underlying database about what should be there, right? Like, so a list of users, a list of apps, et cetera. It sort of synchronized that. And that needs to complete before the next process happens, the process that most people care about. They care about the actual applications. How do they synchronize? So the central builds out a list of things to synchronize. The RIM inserts those into the database, and if that's complete successfully, it'll move on to the next part here. The next part is where the repository on the central makes a request to the engine on the central to build out a list of chunks to synchronize. The engine builds those chunks, and then it's delivered to the RIM where it is merged back into the app that's on the RIM. If the RIM node fails a hash check, it does a hash check of that chunk. It says, what do I expect this file to contain? If it doesn't contain that hash, then it fails and tries again. It's sort of just an overview of how synchronization works between nodes. There really are two parts that could possibly go wrong, and two parts which are generally classified under synchronized persistence. So here, shared persistence. What is that? And this is sort of a high-level overview of the builds that have shared persistence. This is the 3.0 track. I made a mark here of introductory shared persistence in 3.01 and 3.11. Some customers, if they were experiencing endemic problems, they were moved to that and have since moved on in general to later builds. The 3.12 is the sort of landmark release where shared persistence is baked into the installer. And the latest we have is 3.14, as Troy mentioned there. It's always good to go to the latest, but we do have essentially 5 releases out in the 3-track that have it in there, 3 of which are obvious to the end user, and 2 of which require additional configuration. If you're going to target shared persistence, certainly go to 3.12 or higher. That is the sort of gold standard from the perspective of product and R&D. So what is shared persistence? This is a sort of basic model of shared persistence. We have 1 copy of the Postgres database, and we have 1 copy of apps. The RIM nodes reach out to the central's Postgres database or apps. So there's no need to synchronize between nodes. There's no replication of databases, and there's no replication of apps. There's 1 central store of those. And this is just a basic model. You can do a slightly more advanced model where you've got Postgres and the apps living on another server. Works just the same. It's just we've now abstracted Postgres from the physical server that runs Qlik. And if you want to go to the more advanced model, we now have Postgres on its own dedicated node, and we have the data files living on a file share, a Windows attached storage device, so a SAN. The sort of power of this model, this architectural model, is it really allows you to abstract the core components of a Qlik site, the database and the apps, from the confines of a particular server. You don't need to rely on the uptime of a central server. You can rely on the uptime of a SAN, which is going to be far more reliable than any particular server that you have in your environment. Additionally, Postgres can be configured, and I'll cover that a little bit more down the line. Postgres and the apps can be configured in such a way so that there's really is advanced higher availability and disaster recovery, which wouldn't be possible under the previous model. Some of you may have had experiences with QlikView, and this sort of model looks pretty similar to how QlikView works at a high level. So the question is, how is this different, right? Postgres, it's a database. It handles things. Traditionally, QlikView, it will store the metadata about a site in static XML files, which has to update. Postgres is an actual database. It handles database operations. It can queue processes. It can have some logic to it. If you try to do something bad, it'll complain. So we're not relying on XML files on disk. We're relying on a database to handle the metadata. And additionally, file locking, one of the major concerns with QlikView, especially with the PGO files, it's not as big of a deal in QlikSense. The file locking on applications is relatively minimal compared to the file locking on PGOs. If you were to ever sort of monitor the I/O on PGO files in a busy environment, it would be quite high. Not the case in QlikSense. So they share some similarities, but fundamentally they're quite a bit different. So we'll go over here the sort of positives of both persistence nodes, why users might want to use them, and what they mean for you. This is sort of high-level listing, and then we'll go into details. So benefit of synchronized persistence is the replication delays happen on the back end, right? So you import an application to your site. That application then is replicated across however many nodes you have. If that application is not on a given node, then the users won't see it in the hub, and they won't try to click on it and open it. That can be a benefit. It can also be a downside in the sense that the replication delays, they take however long they're going to take. There's not necessarily a deterministic logic to it. So planning out, especially if you're doing more advanced things like on-demand app generation, where users are really waiting for that application to replicate, it can be difficult to troubleshoot and implement. I put this as a positive based on conversations I've had with customers, but there's an illusion of redundancy. There's an illusion that we have the Postgres database on both nodes and apps on both nodes. So, if the central goes down, we have duplicate copies. And I mean, in reality, if your site loses your central node under synchronized persistence, you're going to have problems. It may not be immediate, but you're going to have significant issues. There's some weird things like extensions that run through the central node. Licensing goes to the central node. There are a couple of sort of edge cases. The existing users likely would be able to stay online, assuming they're not using the proxy on the central. But in reality, if you're going to restore that site, there's significant work from an administrative standpoint that's not necessarily obvious to do. It's not as though you click a button and just restore things. Some of you may have experienced that, and it definitely requires a little bit of work. But this is considered a benefit by some customers I've had conversations with. Additionally, DMZs. DMZs are very easy to work with in synchronized persistence because you can just install a proxy. It only needs to have local rights. It doesn't need to have rights on a remote file share. Relatively easy to deploy. All you need is ports opened on the firewall. So from a change request standpoint, relatively easy to implement. You don't really need to involve too many other teams. You just need to open up a couple of ports. Additionally, may not be applicable to many customers, but for some customers, they really have like the ability to have nodes in different regions, have a central node that's in EMEA, have a North American node, maybe have a node that's in Singapore, so the users in those regions can access that local QlikSense site. This is considered a benefit, and this is something that is not really going to be possible with shared persistence. Additionally, I'm making mention of this is that the status quo has sunk costs, right? You've already worked this out. Things are working, hopefully, and why do you necessarily need to move in a different direction? And I'll cover that in a little bit. But this is definitely a benefit in some sense. I would say that you need to take plans on moving to shared persistence because that's how things will go, which I'll cover here in a second. But this is considered a roadblock for making the move for some customers. So the benefits of shared persistence is that replication is more reliable. There's no real sync delay, and it's more predictable at scale, right? You're going to be adding in a RIM node. The RIM node requires no overhead to synchronize. There's no magic synchronization that's going on by the repositories. It's reaching out to a remote source, and it's opening that remote source and that remote source has a deterministic amount of file size, right? Especially with apps. You know if your app's a gig or not. And you can test that on a network and see whether the network can accommodate scaling out to that. Replication is more reliable because there's no synchronization problems, which some of you may have encountered. There's no sync delay because there is no sync to occur. And it's more predictable in the sense that you really only need to check out and have a sense of the network latency and bandwidth between the two boxes. There's no other real calculations that need to go into it. Disaster recovery and high availability is a lot more flexible to accommodate in a shared persistence model because we're abstracting the core functionality that runs Qlik Sense from the services that the end users use and what the administrators care about. Postgres, like I said, doesn't need to live on the central node. It doesn't need to live on the node with the apps at all. Live on its own server, and you can have Windows clustering set up there, or stream replication on Postgres. There are a lot of options. I'll cover some of those later. Additionally, to be blunt, this is how persistence will be going forward. It's not clear when this changeover will take place, when you won't have an option of going the other route. It's not in 3.2, but I did note in 3.2, the technical preview, that when you try to upgrade, it does prompt you whether you want to go to shared persistence or sync persistence. And so in practice for system admins, plans need to be made. Teams need to be involved. You need to analyze your environment and see, how am I impacted? Is it going to be a relatively easy transition, or do I perhaps use DMZs or have servers in different geographical regions? Maybe I want to invest in revamping our disaster recovery and high availability for whatever the requirements and needs of the business are. So I'll go over here, recommended configurations. One benefit of this sort of change in model is that R&D is being a little bit more proactive or prescriptive in describing what they recommend. Tier 1 is their classification of things that are relatively easy to configure, frequently tested, fully supported. Tier 2, more difficult to configure, frequently tested, fully supported. By more difficult, it typically means you either need to have someone who has experience in that, like Windows clustering, or Postgres administration. Additionally, Qlik Consulting Services can also do this, but in general, it's not super easy out of the box. Tier 3, limited testing, but should work from a conceptual standpoint. I'll give examples down the road, but one of the benefits of this is that from a testing standpoint, we have a clear paradigm of what we can test and what we need to focus more on testing. So things are expected to move up tiers, go from tier 3 to tier 2. Product enhancements can also impact there, so R&D can target things to move up into fully supported. So example of tier 1, a single node. Has always been supported, will always be supported. Nothing too fancy here. Tier 1 again, 2 machines. Fully supported, always been supported, will continue to be supported. Not really difficult to configure. Moving on, we have another example of, we have some growth here. We have a central, and then we have 2 consume nodes with proxies and engines. And we have a load balancer out there who's balancing the load between the proxies. Fully supported, always supported, no change there. A little bit more complicated setup here. We have a tier 1. We've got consume nodes, a dedicated reload node, and then a development node. Again, always been supported, will always be supported. Tier 1. This is the maximum scale out that R&D is recommending. And it's a little bit hard here, and I'll cover it in the next slide. But we have a lot going on here. We have 4 engines and proxies, got a load balancer, 2 reload nodes, a development node, and then we have Postgres on a separate server and the apps on a separate server. The key distinction here, though, is not particularly obvious by the previous diagram, but here we have 8 engine nodes. We have 8 instances where there are engines. The key distinction here is that if you have greater than 6 engines in an environment, that includes centrals, engines, proxies and engines, and schedulers, you will need to have a dedicated persistence layer, meaning that Postgres will need to live on a separate server. The server doesn't have to be particularly beefy. I've not gotten any indication from product or consulting services that they're making any changes to the sort of architecture and planning of a site. It doesn't need to have a ton of RAM, a ton of CPU. Definitely have multiple CPU cores and, I mean, relatively minimal RAM. The real benefit there is that now we're running a database server, right? So disk I/O matters a lot. So investing in SSDs here would definitely get you more bang for the buck than trying to throw 256 gigs of RAM onto there. So this is another example of something that's tier 2. It's fully supported, tested. It's just a little bit more difficult to work with. So here we have a DMZ deployment under a shared persistence model, and we have a third-party reverse proxy tunneling users inside the network. And the reason why they're doing that is because the proxy node now needs NT rights on the file share, which is not reasonable to configure and put out into a DMZ for most companies. Very few companies have, security teams will be okay with that sort of configuration. They really only want ports open. So a proxy node in the DMZ consequently is not really a live option. It may be depending on your local policies, but in general it's not recommended. Another option here. So we have high availability. We have stream replication configured between Postgres nodes, and we have DFS, and do make a note here that this is single write master. It's not going two ways. It's going one way. But we have replication of the apps there. So we have high availability set up there. If the Postgres server goes down, you see there's IP binding there. You can change the IP binding in the config files for the sync site, and then move on, and services restored. Another high availability option. We have Microsoft clustering going on that's living on a SAN. It's a little bit more difficult to configure in the sense that you really need to have Microsoft clustering experience. But if your organization already has that, then great. Leverage that experience and knowledge and put that to use in your SAN site to sort of gain higher availability. I say higher in the sense that if you're trying to target triple nines or however many nines, that's going to be a little bit more difficult to configure. Definitely reach out to the account team and try to see what options are available. But being realistic, there still needs to be a switchover from something. So you're going to have to figure out a mechanism to do that switchover. That can be automated and scripted and gotten down to be quite fast. I know one of the senior product managers here, he can switch over an environment within a couple of minutes from one Postgres node to another. But again, it's going to take a little bit of work. So definitely, it's not straightforwardly done out of the box, but you can configure it this way. It takes a little bit of work. So tier 3, more than 8 nodes in a cluster, and that's going to be engine nodes. That's just not supported. That's not something that R&D has tested enough to be ensure that it's going to work. Other things that aren't going to be supported, separate data centers with less than LAN speed connections. LAN speed is a little bit ephemeral. It's a little bit hard to quantify. It's not a precise number, but they are working, R&D is working on testing out scenarios where they can start saying you need to have this latency, this bandwidth, which should unlock a little bit more flexibility in terms of your data centers. Another thing that's not going to be supported is non-Windows file shares, things that aren't directly attached to Windows, so NAS devices. That's something that if you're interested in that, I'll cover it a little bit later. R&D is definitely interested in running some tests against your NAS because there is variability there. There's no in principle reason why it can't be supported. You really just need to have a certain amount of IOPS on the disk, but it just needs to be tested a little bit more rigorously. Additionally, less than gigabits networks on the file share. So you need to have a gigabit network to be supported. So we'll sort of go over the shared persistence requirements. It's sort of a reflection of the previous slide and some of the stuff we covered earlier, but just to be concise, it needs to be 8 nodes or less. That really should be a less than or equal sign. Additionally, you need to have NT rights on the file share, so no DMZs are really going to be a live option. Reverse proxies or load balancers that can act as reverse proxies to tunnel users inside are really going to be needed. A lot of organizations have those in-house. It's just a matter of getting the teams in line and getting that configured, because typically the sysadmins don't have that background. If they do, great, but it does take a little bit more coordination between individuals in an organization. You also need to have gigabit, aka LAN speed connections between the nodes. That's something that most customers already have, but it's something to take note of and just review your environment. And you also need to have Windows attached storage, a SAN for the share. We need to be able to RDP into a box and see that disk attached to a Windows device. It is a D drive somewhere. So in terms of what's coming, how are they adapting what currently is going to be taken away, like DMZs, to the new persistence model? They're working on more advanced load balancing. Currently, it really is just pure round robin. There's no CPU with RAM overload like from Qlik view or random or loaded document. There's no preferential logic there. They're working on adding a little bit more flexibility there to allow users environments to scale out, really. They do have a plan for DMZ deployments. There's no in principle reason why a proxy needs to have NT rights on the file share. All the JavaScript and CSS and PNG files, those are held locally. But currently under the configuration, it does need to have NT rights. But they are trying to accommodate that, so there's a proxy that could live in the DMZ, because it is a little bit more difficult to coordinate those teams and get a reverse proxy set up and configured. They do have a plan for global deployments. That's something that they want to accommodate. They can't accommodate under shared persistence right now, so they want to be very straightforward about it, but it is something that they want to accommodate. Additionally, they want to have some work-sensitive testing and support for some alternative configurations for high availability. So things like NAS devices, Linux for Postgres. I mean, in principle, conceptually, Postgres is just a database. As long as it does database things in an expected manner, it'll work fine. Other things like Samba for file shares, limited testing is going on, but they definitely want to target things like that to allow more flexibility, especially in the cloud. What does this mean for you guys? What are the upgrade paths? Well, the upgrade path really is get on 3.1 SR2 or higher. We have a good article in the portal which describes how to go through that. But 3.1 SR2 or higher, so 3.1.2, 3.1.3, or 3.1.4, that's going to be the target builds you're going to need to go to. One concern I've heard is that traditionally there's been a reliance on the service release track, mainly because there is more frequent updates there, or at least historically there's a bit more updates. For example, if you went to 2.1.1 when it came out in September or August, you would have essentially needed to wait 6 months if you had found a bug right when it was released. That's not the case in the 3.1 track. There have been quite a few releases, and there's been quite a push and understanding that if customers are going to be going down this track, they need to have frequent updates to things. They can't wait around 6 months. So the upgrade path really is upgrade to 3.1.2 or higher. Practically what it means is have a backup. There was a good presentation on a previous TechSpert Thursday by Andrew, I believe, which went over this, but definitely have a backup. Always have a backup and have another one if you're unsure. Plan out the implications for your deployments. What does this mean for you? Do you have DMZs? Do you have a distributed environment? Do you use more complicated things that may be possibly impacted by upgrading to a feature release? Things like APIs, mashups, things that are a little bit non-standard in the sense that you have to do some work to configure them. You definitely need to test those before deploying to prod. Additionally, always reach out to your account manager and try to discuss how you can leverage this new architecture for you to best fit your use case. Some customers have been quite happy with the availability, high availability that they can configure. It unlocks a lot of options. Whether those are things you want to use in your environment is really depends on the requirements of the environment. The account manager definitely can triage things and reach out to the appropriate folks, the technical folks, to have a discussion there. So practically what it means for you is, does your deployment use any functionality which won't work? Do you use DMZs? Do you have NASs? Do you have a distributed network? If you do, then what can you do to get around that? Do you have reverse proxies environmentally that you can use? Do you really need to have those nodes in separate environments? Can they be separate ClickSense sites? Additionally, learn from other customers. Search our knowledge base. There's an ever-expanding wealth of knowledge of the experiences we've had with customers. There's an official documentation on an article, 25817 is the article ID, but it's basically a pretty comprehensive guide of how to upgrade to shared persistence and how to configure some more advanced things. But also just search for articles. I mean, if during the shared persistence configuration, you have to run a command to truncate some tables. If you don't do that, that means you won't be able to delete old applications. And there's an article for that. It's a very clear error code. There's a very clear resolution. So definitely search out in the portal and try to see what is out there. Community can also work, although this is relatively new, so I don't know quite how much is propagated out there. Support, I mean, we're always welcome to have conversations. Practically speaking, we can't always do upgrades for every customer, but we're definitely there to have a conversation if need be. But account managers tend to be able to triage things a little bit better and understand what the business cases are. So we'll go ahead and move to the question and answer section of the panel. So please go ahead and submit your questions by the chat functionality.
Okay, are you able to find the Q&A, Levi? It's in the little drop down from the top of the WebEx menu. First option.
Yep, I'm about to pull it up. Okay, Q&A. Expand it out and see what has been asked. Okay.
Yeah, as Levi mentioned, go ahead and submit your questions in the Q&A panel of your WebEx. So we've already got a few questions come in.
Yep. So there's a question about a shared persistence being a single point of failure. How can HA be architected? Do make a note if the stuff we covered wasn't sufficient. But in brief, you can do things like this or this. This allows a little bit more flexibility for HA and DR. And again, there is an illusion of redundancy under the old model. There's no real redundancy. The central node still is very integral to the operations. So definitely make a note of that. It doesn't answer the question. Can the RIM node be upgraded to a central node if needed? In practice, it's difficult because you'd essentially need to back up a site and restore it to another node. That's something definitely account teams and would be able to integrate you with and see what works. Under the new model, you don't necessarily need to have a beefier central node. It's not actually doing that anything much more. Under this basic model, the only thing that really is going to be pegged is going to be Postgres, and practically speaking, Postgres is very efficient. I've done extensive load testing for a variety of issues where I'm throwing tons of load at RIM nodes. The central node is not being pegged at all. Postgres is not using a lot of CPU or RAM. So there's no real need to re-architect a central node. The traditional model is that a VM for a central node is perfectly fine. Having maybe 4 to 8 cores, 16 to 32 gigs of RAM, not very beefy compared to RIM nodes. Under the new model, there's no changes there architecturally. Postgres is not using that much more in terms of standard CPU or RAM. Disk becomes more important, so as you scale out, definitely be mindful of the I/O on the attached storage, and especially if you're in AWS. It's a little bit more complicated there, but there are different storage tiers there. Is there a concept of a central? Yes. I mean, the central still does some things. It depends on the configuration, right? But if you have the central set as a master scheduler, so if you have a RIM node that's doing reloads, the central is still coordinating reloads. But in terms of the traditional concept of a central in the sense of coordinating reloads, that's not there anymore, or coordinating synchronization. It doesn't coordinate synchronization. It does some other things, so the central still needs to be running, but it's not as centrally as it used to be. 8 nodes mean engines or include disaster recovery nodes. 8 nodes is if your QMC has 8 different nodes which have engines, that covers that. If the DR nodes are included inside of the QMC, they are included in that calculation. If you have things like DR going on here, that standby node, right, is not active. It's not actually doing anything. Also, it's not having an engine. But if they're in the QMC, they count. DMZs with shared persistence, they don't work. Our question is whether they work. Not out of the box, you'll need to have a reverse proxy or a load balancer there to tunnel users inside. Most organizations have those, and they have teams that know how to configure those. It just takes a little bit of work to get those folks on calls and sort of plan it out. Is Qlik committed to Postgres going forward? What I've heard is it's going to be Postgres for the near-term future. I know there was a mention of Cassandra at Connections last year. I have not seen any indication that Cassandra is coming right now. I'm not on board with R&D's discussions, but practically speaking, it's going to be Postgres for the near-term future. One other thing they are targeting, though, is a little bit of flexibility, and this is even longer term than sort of medium term, is that in practice, as long as it's a database, it should work. So they need to do more testing on trying to see whether they can even have this not in Postgres, have it in something that the organization has more experience with, like Oracle or Microsoft SQL. But that's quite a bit down the road, so definitely check release notes there. The 8-node limit, why does that matter? The concern really is a matter of file locking, because we have multiple engines potentially locking the same apps. Coordinating that between the nodes, they've only got extensive data up to 8 nodes. I mean, as with all things that aren't supported, they may work. There are customers who do unsupported things all the time that have worked. But from a support standpoint, from an R&D standpoint, if you have a problem with that configuration, that's not something that we can necessarily expect to work. AWS between different regions. If you'll put your email address in there, I can follow up on that. But my first pass would say if the AWS is in the same region and there's a gigabit connection between the nodes, that's perfectly fine. But do ping me your email address there, and I'll try to follow up there. NAS on top of a SAN, supported for the file share. I am by no means a storage expert, but if we can't log into a Windows device and see that drive, if it's not a true SAN, then it wouldn't be supported. But again, that's something that R&D is interested in testing out. They have a set of scenarios that they want to test out and have customers run and experience. You mentioned NetApp here. Traditionally, NetApp has been more conducive for a file share for Qlik products because you can configure it to be quite responsive. But that's something definitely account teams will be able to coordinate with.
Okay, Levi, we got time for one more question.
Is the dedicated persistence node required for 6+ engine nodes? Yes, that is going to be a requirement. It should be there, and let's scan through some other questions. Yes, and shared persistence will not be in the service release track. The target there is not to make changes in the service release track, so it'll only be in the feature release track. So that's something you will need to be on 3.1 or wait around until a major version like 4.
Okay.
Yep.
Thank you once again, everybody, and have a great rest of the day. Thanks.